it's mind-boggling that you can design a product and sort of manufacture it the way you would manufacture on the shop floor, using these same physics-based laws as the backbone.
Exactly. So,
and then you can, can you also now optimize the manufacturing in silico itself?
Yeah, absolutely. So that's the direction we're going in. But before I answer that, I do want to touch upon another experience I had at IITM, right? So I was a mechanical engineering student, but I took courses in the metallurgy department, which is where I got exposed to metal forming and things like that. And of course, there are labs here for that. And as a first year student, I think all of us did welding, but we didn't really understand, okay, how do I know that the weld quality is good? Okay.
Yeah.
In the workshop, maybe visual inspection and saying, okay, this is good enough, but there's more to that, right? So some of the metallurgy, the courses I took in the metallurgy department opened my eyes to, for the first time, quality that comes from manufacturing, right? And so that again feeds into the overall experience I had from simulation. So going back to your question, so absolutely yes. So the goal is to try and optimize the manufacturing process from multiple angles. The first could be just from a cost perspective. How much material do you need? Okay, so you're going through sheet metal manufacturing, stamping processes. There's always going to be some wastage. How can you minimize that wastage, right? So that's a cost question, okay? And you can use simulation to figure out, okay, how much sheet do you need, because the sheet's going to be bent and cut, and different operations are going to be performed on that. So to optimize the material. So that's a big factor in manufacturing optimization. Then during the manufacturing process, how fast do you manufacture it? How quickly can you weld, okay? All of those things start affecting the quality of the product that you're making, right? So there's always an optimization element that comes into play when it comes to manufacturing. Last point, which is actually very exciting for us, is to simulate the entire assembly process. So think of again, let's use a car as an example. Now you have different suppliers providing different parts, or maybe parts are coming from different factories, and they all have to be assembled together. Now, how do you know that everything is going to come together in the proper manner? The gaps, you don't want a small gap that could affect the acoustics or the noise or the vibration characteristics. How do you simulate all of that to make sure that the final car that you assemble is going to meet your requirements? So all of that can also be simulated, and to give in this case, the car makers the confidence that their processes are optimal, so that first of all, it's fast enough, there's less wastage, that everything is going to come together with matching the design intent.